All right, ninth graders, I am going to go over the work and power examples that you'll be doing today in class, or ones that are like those. And yesterday in the notes, I gave you two different equations, really three different equations. The first one was the equation for work. Work equals force times distance. And that can be written in this form. That should be familiar to you from what we've done in class before. Also, we have power equals work divided by time, and that's this one right here. Power equals work divided by time. And since work is force times distance, then we can put force times distance in where work is on this equation. So force times distance equals power times time, or power equals force times distance over time. Once again, you have three equations in one on each of these circles. All right, so let's take a look at number one. Number one, how much work is done when you use 40 newtons of force to push a box 10 meters? So first of all, what's the question asking us for? And it's saying how much work. So we put in W equals question mark. And it says that we have 40 newtons of force. And we say that we're pushing our box 10 meters. 10 meters is a distance. And so what do we do if we have work, force, and distance? You look at this equation right here. Work equals force times distance. So I'm going to write that down. Work equals force times distance. And now I'm going to substitute those numbers in. 40 newtons, 10 meters, and that's 400 Newton meters. But remember from the notes, I said that Newton meters are the same thing as joules. So we do 400 joules of work. All right, moving on to number two. How much force was needed if you did 300 joules of work to lift a weight 1.5 meters? And so here the question is asking us for force. And so what else do we have? Well, we have 300 joules of work, and we have a distance of 1.5 meters. All right, so now we look at that same equation wheel, or whatever you want to call that. Work equals force times distance. And since we want force, force will equal work over distance. And that's going to be 300 joules divided by 1.5 meters. And that's going to equal 200 newtons. That's what force is measured in, newtons. All right, moving on to number three. How far did you move a chair if you pushed it with a force? Or first of all, how far, that's a distance. Did you move a chair if you push it with a force of 30 newtons and did 900 joules of work? So I have the same three letters, which means I should be using this equation, but now I'm looking for distance. So D equals W over F, and that's going to be 900 joules divided by 30 newtons, and that's going to equal 30 meters. All right, now let's do some power problems. Number four, if it takes 400 joules of work to go up the stairs and you do it in 2 seconds, how much power did you use? All right, so first of all, here are the power equations again. Power equals work divided by time. And so we start out, we have 400 joules of work. We do it in 2 seconds. And the question is, how much power did we use to do that? Well, P equals W over T. So now substitute your numbers in. 400 joules divided by 2 seconds equals 200 joules per second. joules over seconds. But a joule per second is what we call a watt. All right, moving on to number 5. If a horse pulls a wagon and uses 1500 watts for 5 seconds, so 1500 watts is power, 5 seconds is a time, how much work did it do? That is obviously asking for work. So how do we do that? Work equals power times time. So 1500 watts times 5 seconds equals 7,500 joules. And finally, if I push an object with a force of 100 newtons for 5 seconds and it travels 20 meters, how much power did I use? Okay, so again, this is looking for power. And this one says, if I push an object with a force of 100 newtons, so that's a force. I've got 5 seconds here, and 20 meters, that's a distance. All right, now I have F, T, D, and P. If I look at the equation I've been using, I don't have F or D, I have P and T there, but no F and D. But remember that work is F times D. So I'm gonna write it out like this. Okay, once again, F times D is the same thing as W. It's just broken down a little bit. All right, so P equals F times D over T. And now I can substitute those values in. So 100 newtons times 20 meters over 5 seconds. 100 times 20 is 2,000 Newton meters, that's a joule, over 5 seconds. And that equals 400 watts. All right, that's it.